P-Link, all that stuff, go ahead and hook it up to the panel, wire it in. Obviously set the addresses on everything first, and then wire all that up, and then you can run the learn mode. And the panel is basically going to go out and look at everything that's connected to it and just kind of pull it into its program. So it's not something where you can run a learn mode and then the system's ready to go. It just kind of gives you a head start on your programming. So you could run your learn mode, then you could upload that program from the panel to your laptop. And then you've already got all your devices in there. So you don't have to go through and say 0.1's a smoke, 0.2's a heat. That stuff will already be there. So it just makes the programming side a little quicker. Analog addressable sensing technology. So the detectors are always talking to the panel. And you can set up drift alert emails. IP reporting or DACT reporting. 99 software zones, and this is on the programming side. You can have up to 99 software zones on the small panels. You can have up to 1,500 software zones on the AFC 1000. All the panels charge 55 amp hour batteries, and then we use dip switch addressing for everything. Take a look at the display here. So that's the display on the AFC 1000. And let's take a look at the board here. Bottom left is going to be the dedicated alarm, trouble, and supervisory relays. They are dedicated, so you can't change them. They are what they are, but they're there if you need them. There's your battery charging terminals. Your 6 NAC circuits here. And those are rated at 3 amps each. But you got to keep in mind, you got a 10 amp total that you're working with on the AFC 1000. So if you're maxing those out at 3 amps on each one, you're only going to have 3 NAC circuits. 2 separate P-Link connections. They both do the same thing. We'll talk about those a little bit more when we get to the P-Link stuff too. There's your SLC loop connection there for all your devices, your detectors, your modules, all that stuff. Up to the top right of the board, you got the PCOM connection. That's for your IP reporting or your email functions. That's your connection to the building's network. That's also your connection if you're going to use direct connection from your laptop for programming. And then you got your 4 I/O circuits there. So those are only rated at 1 amp each. And again, those can be programmed as an input or an output. Again, if you got any questions, go ahead and throw those in the chat box. We'll answer them as we're going along. Take a look at just a couple quick installation notes. I'm not going to spend a whole lot of time on it. So the panels, the panel displayed, there's the AFC 1000, and that can be surface or semi-flush mounted. That's just the shape of the cabinet. You don't have to order anything special to do the semi-flush. And then general notes here, mounted on an interior wall, operating temperature 32 to 120, don't exceed 85% humidity, verify it's properly grounded. So all standard stuff here. Install it indoors in a climate controlled area. This is what, so that whole dead front comes off of there with the door, and then that's what the inside of the cabinet will look like. Got that little keyhole up top for mounting. And then I thought I had a picture of the knockouts, but I guess not. So most of these knockouts are 3/4 inch, and then there's a couple 1/2 inch ones basically up there on the top left by where the AC power's at. But most of the knockouts on the cabinet are 3/4. Electrical specs 120 or 240. There's just a little jumper you move in there to change that. Must be on a dedicated circuit, and you can use up to 12 gauge wire. Hot, black, white, neutral, green, ground. I mean, you can kind of see that jumper right there on the left. Battery circuit, 27.3 volts. The voltage is always there, so if you disconnect your batteries, you can meter that charging circuit there, and you should see 27.3 volts all the time. Sealed lead acid. This note here is important. So the enclosure will house either two 18 amp hour batteries or two 8 amp hour batteries. 12 amp hours don't fit inside the cabinet. So if you need bigger than 8 amp hours, jump straight up to 18. That's what fits in the cabinet. Panel can charge up to 55. You obviously are just going to have to put those in a separate battery cabinet. We've got battery calcs for everything on our website. Just a note here, if you're doing a standard system, NFPA 72 requires 24 hours of standby with 5 minutes of alarm, and you can just set that on your battery calc, what you're using. So you put it on there if you're doing 24 hours, 5 minutes, or 48, 15, whatever you're doing, you just put that on the battery calc. And then we say replace them every 5 years. I think most people do like 3 or so. And then there's your connection. So two 12-volt batteries wired up in series gives you your 24. Question here about the difference between AFC and IPA. AFC, anybody can go buy from a distributor. IPA is a private dealer panel only, so you have to be a dealer to use IPA. And the main differences are in the programming. The IPA has different features that the AFC can't do, such as smoke control. Smoke control is a big one. Some other things in there that IPAs can do more points. Let's look at the SLC loop here. Addressable detectors. First one's the Pad 100 PD. That's going to be the smoke detector. It has adjustable sensitivity, 1.1 to 3.5, although I don't think anybody really changes it. It does not have a magnet test. That's a big question. So you can't do a magnet test, but we do have a way through the keypad where you can just go in and activate a detector. The PhD, let's go down to the heat detector first. We'll come back to the PhD. So the HD is the heat detector. We only have one, and you just set through the software if you want it to be fixed temp between 135 and 185. And if you want to add on the rate of rise part, there's just a checkbox for that. So it can be fixed only or combo, and you just set that through the software. You can also select in the software if you want to also get a low temperature signal from the heat detector. So maybe you want to put it in a riser room or something, and you want to get that low temp supervisory at 40 degrees. So you can use it for that too. And you can do it you can be doing both things at one time. So you can get alarm at 135 or rate of rise, and also supervisory at 40 degree for low temp. Now the PhD has all the same options as the PD and the HD. So you can still do the fixed rate of rise. You can still go 135 to 185. You can get low temp. You can still adjust your sensitivity for the smoke detector side. And the other nice thing about the PhD, depending on how you add it to the program, you can do it as what's called a PhD split. And then it'll separate your photo signal from your heat signal. So it still is just going to be one detector. It still only takes one address on the loop, but you can actually get separate signals for the smoke and the heat. So you could use it for your elevator to separate out your shunt trip and your fire hat. So you can have one detector there that's doing both purposes for you. The CO detector, that's got its own slide here in a second, so we'll kind of come back to that. And then we've got two different duct detectors. The duct is a 2-wire SLC loop connection only. The duct R has a built-in relay, but it also requires 24 volts DC. And then there's a couple other things that go along with that we'll look at in a second. Let's jump over to the CO detector here. So you can see these thresholds here that are defaulted on the device. You can't change these. 70 parts for 2 hours. That's how long it takes to get an alarm. So we'd have to see 70 parts for 2 hours, 150 for 30 minutes, or 400 for 10 minutes. So the main thing with that is when it comes to testing, if you put the panel into walk test mode, it's going to bypass those thresholds. So as soon as you put CO on it, it'll go right into alarm. So keep that in mind when you want to test your CO detectors. Make sure you're using walk test mode. And then an 8-year lifespan. So that's 8 years from the time that it's powered up on the system. And the CO detector itself is actually going to keep track of that. So even if you were to take that CO detector down and even take it to a totally different fire panel, it's still going to have the right life remaining in there. The DRTS is a remote test switch for the duct R. The duct R is the only one that you can hook up a physically connected to the duct detector remote test station. The duct R is the only one that you can do that on. That's what it looks like up on the top right there. Now, if you use the duct, which again, that one is just the 2-wire SLC loop connection, we do have a way to kind of mimic a remote test, which we'll come back to in a minute here. But if you're required to have that remote test station that's actually wired to the unit, you're going to have to use the duct R for that. Again, it does require 24 volts DC power. It does have a bigger relay in there than what the rest of our SLC stuff does. So 8 amps at 30 volts, 10 amps at 250. And then you can use that DRTS that's on the top right, or you can just use the standard MS series stuff on there too. Let's look at the bases here. We got the AB6 and AB4. That's just your standard 6-inch and 4-inch base. 6-inch is the one that's pictured. That's what everybody uses for the most part. 2 different sounder bases. The SB on the left, that's the standard one, and the low frequency sounder base on the right there. That's the one that's more commonly used now. The nice thing about these bases is they don't take an address. They're just a sub point of the detector head. So if you got a smoke detector at address 5, you put that on a sounder base. Now that sounder base is address 5.0. So it's still totally independent as far as programming goes. You can map it to whatever you want, but it's not going to take an extra address off of your loop. So you could even do a smoke detector on a low frequency sounder base and then have a CO detector in the same room just on a regular base, and you can route the CO signals through that same sounder base. So you can have that sounder base doing temporal 4 when the CO is active and doing temporal 3 when the smoke's active. So they don't take addresses, but they are totally independent programming wise. Next one here is the relay base. Same thing. Doesn't take an address, but you can program it however you want. Just gives you a little relay there if you'd rather use the relay base instead of using a separate relay module. Then we've got the isolator base. These actually are more mechanical devices. The panel doesn't even actually know it's installed. It just kind of does its thing on its own. So that's a short circuit isolator base. And what that allows you to do is to kind of section out your system. So maybe you've got 4 floors and you want to put an isolator base on each floor so that a short circuit on the 4th floor SLC doesn't kill the SLC loop for the whole building. So you can use these isolator bases for that. They're not limited in any way. You can use as many as you want on a system. It doesn't affect your loop at all, or I guess I should say it doesn't negatively affect your loop at all. And then again, they're kind of just a mechanical device. So when it sees a short, it opens up and the little LED comes on there. Once you clear that short, it clears on its own and goes back to normal. And again, the panel doesn't know it's there, so it's just kind of on the loop doing its thing. We also have a module version of the isolator, which we'll talk about shortly. Last one here is the speaker base. That one looks exactly like the low frequency sounder on the bottom right, except for the speaker base is not addressable. It's just a speaker. So it just allows you to run all of your, if you're doing a voice evac system, instead of having to run, your speaker wires to this spot over here for the speaker and then run your SLC over here for the smoke detector or whatever, you can just run it all to the same box and put it all in one little package there. Let's take a look at the modules here. First up, the PSSA and DA. That's the single or dual action pull station. It's just going to be our conventional pull station with a mini module pre-mounted on the back. So the MIM is the mini module. It is really small if you haven't seen one. They're really small, and then they just have wire leads coming out. So they fit nicely on the back of a pull station. They're nice to just throw in the box behind something that you want to monitor. You don't have to worry about having a separate box to mount it in or anything like that. And if you're not familiar with what the input modules are used for, that's how you monitor anything dry contact. So pull station, flow switch, conventional heat detector, tamper, any of that stuff's going to have to be monitored by one of these input modules here. The single input module is the same thing as the mini. It's just on a 4-square box module version. So it would look similar to what's on the bottom right there. As far as the panel is concerned, they're both the same thing. Just one of them is the mini version, one of them is the standard 4-square version. The dual input module, that's what's actually pictured on the bottom right there. That's going to give you 2 monitor points while also only taking 1 address from your loop. So anything on our SLC loop only takes 1 address regardless of how many functions you get out of it. So that dual input module gives you 2 different inputs, but it only burns 1 address. So you can monitor a flow switch and a tamper on the same module, and you don't have to worry about using up 2 addresses on your loop for that. Next up here, the relay module, the RM. It's just going to give you a relay that you can use for whatever you need it for. Elevator recall, air handler shutdown, dampers, whatever you need it for. The OROI, that's 1 relay and 1 input on the same module, totally independent from each other, but they're on the same module, only take 1 address, and it gives you 2 different functions there. So maybe you're doing elevator shunt trip and you need to monitor that shunt trip power. So you can use the input side to actually monitor the shunt trip power, and then use the relay side to actually perform the shunt trip. So you can kind of kill 2 birds with 1 stone there. Or 2 birds with 1 address, I guess you could say. The TRTI, same thing, except it's doubled. So now you got 2 separate relays, 2 separate inputs, 4 total different functions, all from 1 module, 1 address on your loop. So if you use your modules to your advantage and the options you have there, even that small AFC 50 could still perform a lot of functions. Next one here is the ZM zone module. That is only required if you're trying to monitor conventional 2-wire smoke detectors. And you're going to get 2 Class B zones or 1 Class A. So if you're replacing the conventional panel, maybe they're not going to replace all the zones with addressable devices yet, you can use a zone module in the meantime. We also have a P-Link version that we'll talk about in a little bit. There's that isolator module I mentioned before. Again, just like the base, this module doesn't take an address. Panel doesn't even really know it's there. It just kind of does its thing on its own. The difference on the module is that it gives you 2 isolated branches. So if you were going to do that floor by floor setup, one module would cover 2 floors for you. Speaker module we'll come back to. The NAC module is just basically a monitored output module. So you put 24 volts to the NAC module, and then through the software, through your program, you tell it when to pass that voltage through. Most of the time on our systems, this gets used for doing solenoids, because you can run solenoids off these NAC modules. You could also use it maybe for strobes in ADA rooms or something like that, where you don't really need it to sync, you just need it to be separate. The LED module, that's up on the top right there. So if you need a remote LED, our detector bases don't give you the ability to just wire a remote LED through there. So if you need that, you just need to add these LED modules. They do take an address. Then you can program them to whatever you want. So you can have one LED module that's, you know, programmed to 20 different smoke detectors if you want, however you want to use it. And then the LED K, we're going to come back to that one too. All right, so the speaker module is basically the same thing as the NAC module. It's just used for speaker circuits. So if you wanted to use this in conjunction with the speaker bases, or maybe you just want to use it with whatever speakers you got going on at a certain building. Common use for this would be like in a hotel, when you got a voice evac system, and you want to, you know, you're doing voice evac, but also you want to have the rooms activate individually. So you would install this speaker module outside of each room, and then you could individually activate the speakers inside of that room. So it basically allows you to take a conventional standard voice evac circuit with standard speakers and kind of make it addressable. Make the individual speakers addressable where you can control them separately. You get one Class B or Class A there. The max output is 60 watts. They're really not designed to do, you know, you would really want to use it more for like 1, 2, maybe 3 speakers on the output side. And then, of course, this 520 hertz low frequency, that's what you could do on that individual room control, but that 520 hertz really has nothing to do with the module. That's just your voice evac system that's providing that. So whatever you put into it, it's going to pass it through to the speakers. The LED K is kind of just a multi-purpose utility switch here. You can use it for whatever you want. So you just land it anywhere on the SLC loop, and you can make this your enable disable switch. So maybe you want to have a switch to disable the NACs, one to disable door holders, maybe you want to use one to disable beam detectors in a gym or something when they're doing stuff in there. So you can add these LED Ks and use them for that. This is also what you could use for that duct remote test. I kind of mentioned that before. So you can program this to activate a shutdown relay. Now, it's not going to touch the duct detector. It's just going to activate the shutdown relay on the unit. So you're going to turn it on. You're going to hear the unit shut down. The duct detector is never going to go in alarm. Some fire marshals don't like that. In reality, it's really no different than a remote test on a duct detector. That doesn't really test anything either. So you kind of just got to check with your fire marshal if he's going to be okay with that or not. If you can do it this way, it's definitely easier. You don't have to wire this to the duct detector. You just put this anywhere on the loop. You can program it to all your shutdown relays. Shut down the whole thing at once, whatever you want to do. Excuse me. If you're in New York City, you can also use this for your fan restart after alarms. And then you can use it for a remote drill if you want. Maybe in a school, in the principal's office or something, but it's really just a utility switch. Whatever you need to do, you can use the LED cave for it. And it kind of takes the place. We don't have any programmable buttons on our panels, so this kind of takes the place of that. Let's take a look at our addressing, and then we'll pause for a minute here. So just a reminder here of what's available on each panel. The 50s have 50 addresses, the 100s have 100, and the 1000 has 127 built in, up to 1270 total devices. But when you add the loop card, obviously you just start back over at 1 again, 1 through 127 for each card. That's your loop adder card right there. So the Pad 100 SLCE, each one of those gives you another 127 points. And we're going to use dip switches. If you're not familiar with that, this is what it looks like. It's just binary. You add them up to get whatever address you're looking for. So in this example here, we're looking for the address of 42. So we're going to turn on switches 2, 4, and 6. The value of those switches are 2, 8, and 32. Add them up, you get your 42. If you don't want to do that, just download an app on your phone. They got several different ones that'll tell you exactly what switches to turn on for each address. Subpoints, this is what those look like in the software. So I mentioned the subpoints. For example, the OR OI takes one address, but it has 2 separate points there. So that's what that looks like. The relay is address 3.1. The input side is address 3.2. So you're taking one address, but you're getting 2 independent functions. That's just kind of a list of devices that use the subpoints, and then a note on the subpoints is on the reporting side. If you're doing contact ID reporting, the subpoint's not going to get there to the central station. So what they're going to see in the example of a dual input module here, address 4, you got a water flow and a tamper. They're going to see water flow at address 4, or they're going to see supervisory at address 4. Not a big deal. It's just something you need to make them aware of so that they know, hey, this, if this address comes over with a supervisory, that's the tamper switch. If it comes over with an alarm, that's the water flow. If you do SIA reporting, which not many people do, but if you do use SIA reporting, the sub point actually reports over most of the time. So they will see 4.1 and 4.2 at the central station. All right, let's go ahead and pause here for a minute. Make sure there's no questions in the chat box here, and then we'll look at we're going to look at the P-Link stuff.